So today's topic is dilations. And these are notes for 9-5, your last set of notes before your test. So how many of you ever get your eyes dilated at the eye doctor? Isn't that a fun feeling? Yeah? Right? Your eyes burn, it's hard to see, it's hard to kind of walk. You definitely don't want to drive afterwards, right? The sun hurts your eyes, right?
I was like 7 years old when I first got it.
All right, so, oh, see, I would never have known if you hadn't said anything. So most of you think of a dilation as something that gets larger, right? When they dilate your eyes, your pupils get really huge, right? Well, dilations in mathematics can be a reduction. It can be reduced, something made smaller, or it can be something that's made larger. So dilations doesn't mean that we're making it bigger. So, whoops, let me get a different color. So dilations, the enlargements, it's an E, the enlargement or reduction of a figure. So when you did that sun homework yesterday, you noticed a word. What word did you notice used with dilations? Scale factor. So the scale factor is important. The scale factor indicates how much the figure will enlarge or reduce. So if we want to double the size of a figure, the scale factor is going to be 2. If we want to reduce a figure in half, the scale factor is going to be 1/2. Bless you. So the variable for the scale factor that we're going to use is going to be K. So when K is greater than 0, meaning bigger than 1, and K is always going to be a positive number, the dilation is an enlargement. Oops. All right. Sorry about that. And when K is less than, oh, I shouldn't say greater than 0. Let's try this again. Let's do greater than 1. Sorry. When K is less than 1, meaning it's a fraction between 0 and 1, so 1/2, 1/3, 1/4, 2/5, 3/7, any kind of fraction between 0 and 1, the dilation is a reduction. Palm of my hand, he keeps hitting the wrong stuff. So let's start with something simple. So on this one, our dilation factor right here is 2. So all we're going to do is multiply each and every one of these x and y's here by the scale factor of 2. So I'm going to multiply this by 2, that by 2, that by 2, that by 2. All of these get multiplied by 2. So we're going to find our r prime, s prime, and t prime just by multiplying. So what is negative 5 times 2? Negative 10. So pay attention to your signs when y'all are doing this. 1 times 2 is 2. And then for s, negative 3 times 2 is negative 6. 4 times 2 is 8. For t prime, 2 times 2 is 4. And negative 1 times 2 is negative 2. So let's plot our original figure. We're going to plot our original figure in blue. So plot your r, s, and t, not the new points we came up with, but the old points. And please label them. And then please use a straight edge. I can't up here, but you can, to connect these. Oh, it's really a terrible job, but you get the idea. So there's our original figure, and we should see that original figure expand and get bigger because we multiplied everything by 2. So I'm going to plot our image, because that was our pre-image, so I'm going to plot our image in red. So then plot your R prime, S prime, T prime. Bless you. You'll notice that they've made your grids bigger. So if you got used to the 8x8 grids on the previous homework, these grids are what? 10 by 10. So just be careful. And then connect those. And so, usually you're going to see your pre-image is typically inside of an enlargement. And so here's your enlargement. It's not always right in the middle. You can't expect it to be right in the middle. It's just not how it works. If it's a reduction, then your reduction typically will be inside of your pre-image. So any issues, problems, or concerns with that? So let's talk about what we do with a fraction. So let's look at number 4. So if I have a fraction right here, k is 1/4. My scale factor is 1/4. We're going to multiply everything by 1/4. But anytime we multiply by a fraction that's 1 over something, isn't that the same as dividing by 4 in this case? So if your fraction is 1/4, 1/3, 1/2, 1/5, 1/7, the quick way is just to go through here and divide each of these by 4. That'll be different if we have a fraction like 2/5. We won't do the same thing. But for this case, if it's 1 over something, just divide by that denominator. And then we're going to get our new w prime, x prime, y prime. So write down what you have for those. So perform your division. What happens with the 10/4? Is that a nice pretty number? And you're not always going to. Oftentimes they will give you a nice pretty number, but in this case it doesn't give you a pretty number. So what reduces into 10 and 4? What can you divide both of them by? 2. So 10 divided by 2 is 5, and 4 divided by 2 is 2. So your x value for x prime is 5/2, positive 5/2, and then 0 divided by 4 is still 0. That doesn't change. So if you were to try to reduce or enlarge the point 0, 0, it doesn't change. It still stays the point 0, 0, by the way. And then for y, what's negative 2 over 4 going to be? Negative 1/2. And then negative 8 divided by 4 is negative 2. So let's plot our pre-image. I'm going to plot mine in blue. So w, x, and y. So please connect with a straight edge. Unlike me. So typically when we have a reduction, not always, they're going to make the pre-image a bigger figure, so it's easier for you to plot. When you go to plot your image, your resulting image, plot W prime, X prime, Y prime. Five halves as a mixed number is what? What's 5 halves as a mixed number? 2 and 1/2. So you're just going to count to the right 2 and just a half. So you're going to be plotting in between these two lines here, and then you're going to stay at 0, so you're going to plot right here. And then -1/2 goes to the left, halfway between 0 and -1, and down -2, so you end up being right there for Y prime. And as you can see, our image is inside the pre-image. And that is 1/4 the size of the original. Yes, sir. I can't hear you, dear.
Sorry, what is the
What is the what?
5/2?
What mixed number is that? 5 divided by 2. 2 and 1/2. So we went to from 0, 0, we went to the right 2 and 1/2, right there. And then the Y value is 0, so we don't go up or down. So you plot it on the x-axis right there, between 2 and 3. Right? Now, if you had a fractional point that was like, 3 and 1/3, I'm not going to check to see, did you plot that point exactly at 1/3? You just have to plot in between the integer values, as far as I'm concerned. As long as these values here are correct, and your points are in between the proper integers, you're going to be fine. So any questions on that? Okay, so let's let's move on to the back page. So as we look at the back page, number 5 has a fun fraction, 5 halves, right? So that's not quite as fun. So instead of, we're not going to divide by anything, but let's talk about what the scale factor does. And typically with the scale factor we multiply. The only reason why we divided in the last example was because we had a fraction that had a denominator that was under 1. Otherwise, multiplying by 1/4 and dividing by 4 are the same thing. But when you have any other kind of fraction, as we do here, you're still going to multiply every x and every y by that fraction 5 halves. I highly suggest that you don't do it in your head. Less in your head, more on paper, kill a tree. So, we're going to do our workout here to the side. And so for D, I'm going to take 0 and I'm going to multiply it by 5/2, and I have comma 0, and I'm going to multiply that by 5/2. When I multiply 0 by anything, what do I get? 0. So the scale factor of 5 halves, as I said before, does not affect the point 0, 0. So D and D prime are going to be the same thing, but that's okay. Then let's look at E. So we're going to take E. Its x value is 2, so we're going to put 2/1, because if I multiply a fraction to something that's not a fraction, I want to make it into a fraction. So I'm going to multiply 2 to 5 halves, comma. I'm going to take the 4 and put it over 1, and I'm going to multiply it to 5 halves. Then, don't you see that the 2's here cancel? So our 2's cancel. And what are we left with for our x value? Of 5. And then on the y value, this 2 and the 4, can I reduce them by a 2? So cross cancel. So 2 goes in here once, and 2 goes in here twice. So then, what's 2 times 5? 10 over 1 times 1, which is 1. So we get 10. Now, let's stop here for a moment. This scale factor, is this scale factor bigger than 1 or less than 1? 5 halves, what mixed number is that? We just talked about it. What mixed number is 5 halves? 2.5. Isn't that bigger than 1? So shouldn't this be creating an enlargement? And isn't 5/10 bigger than 2/4? Point-wise? Okay. So then we're going to do the same thing to F and to G. So I'm kind of running out of room, so I'm going to do F and G above. So here's F. So I've got 6/1. That's a terrible 6. I'm going to multiply that to 5 halves. And then my 2/1. Cross cancel. And then multiply what you have left. So 3 times 5 is 15/1. And then we just have a 5/1. And then your G is 4/1. And then this time we have a -2, so pay attention to your signs. And then cross cancel. So we get 2 times 5 is 10/1. It's 10. And then all we have left is a negative times a 5, so that's a -5. Yes? I don't use decimals because what if my fraction were 5/3? Now that's not going to work, right? And it's far easier to work with the fraction, Katie, than it is 2.5 because that means you're cracking out your calculator. And you're most likely not having a calculator on this test. There's no reason for it. So I would be aware of using decimals, changing that scale factor to decimal. So I just wouldn't. Decimals are evil. I know y'all think fractions are evil, but decimals are evil. Okay, so let's go ahead and plot our preimage. We're expecting an enlargement, right? So our preimage, and notice that they've adjusted your coordinate grid here. See where 0, 0 is? We're only mostly in the first quadrant and part of the fourth. So here's 0, 0, which is D. And then 2, 4, which is E. And then 6, 2, which is F. And then 4, 2, -2, which is G. Connect with a straight edge. There's your preimage. Our image is going to be in red, and so we still have 0, 0 for D prime. So they're one and the same point. And then 5, 10. Is this still by tens? 2, 4, 6. Yep. My hair's not cooperating. And then 15, 5. Bless you. Bless you. Bless you. Gotta love those allergies. Or not. Huh? So this time, bless you again, you're blessed forever. This time you can see that your reduction is in a corner, or your pre-image is in a corner of your enlargement. So it's not always going to be in the very center, so don't think that it is. All right, so are there any other questions on here? So I want you to do a couple of problems on your own. I want you to complete, oh, let's see. I want you to do, well, you're going to do more than one. So you are going to do 7, because that's easy. And you're going to do 8, and you're going to do, let's do 9. So 7, 8, 9, all on your own. I'm going to cover this up here while I'm doing it. And then you're going to work on your own, and you can check with those around you. So notice on 7, 8, oh, let's just talk about 7 really quickly. Because actually, they have given you the pre-image, have they not? They haven't. They've given you the pre-image so you don't have to plot it, but they haven't listed these ordered pairs out, have they? So if I were you, I would start off by listing out the ordered pairs of M. And in this case, it's -1, 1, 2, 3. So -1, 3. And then N is 1, 4. And then O is -2, -1. And then P is 1, 2, 3, -4, -2. So before you can even start, you need to list those out yourself first. Then from there, you can apply your scale factor here and multiply every x and every y by that 2 and get your new ones and then plot. So continue from there. You'll notice that they're back to an 8 by 8, right? Do you expect an enlargement or a reduction on this one? Enlargement is correct. What do you notice on this enlargement versus the pre-image and the image on this one? What do you notice about them? Is one inside the other? No. So they don't have to be. They don't have to be, but the pre-image is definitely smaller than the image, so we definitely had an enlargement occur, and that's really what you're looking for. So don't assume that they're always going to be in the middle. I want you to do 8 and 9. So start with naming your ordered pairs first. once you're done with 8, move on to 9. Katie, are you done? If you're not done, you shouldn't be chit-chatting. So as you're finishing up, here are my pictures for 7, 8, and 9, and they're ordered pairs and all of my work. So check, especially your ordered pairs, and see if your ordered pairs match, and then check the picture and see if it looks similar to mine. It should. Does that look fuzzy to you also? It's a little fuzzy. All right, so as you look at, I'm going to make number 11 a little bigger. Can you see that better? See that okay? So as you look at number 11, these directions say identify the scale factor used to graph the image. Which is the pre-image? Is it the smaller one or is it the larger one? So it's the larger one. So we went from something big to something small. So what do we have? An enlargement or reduction? So we have a reduction. So if we have a reduction, what kind of scale factor do we expect to have? Less than 1. So all I would do if I were you would be to take an ordered pair. One set of ordered pairs. You don't have to do all of them. It's nice if you did more than one on a test just to check yourself. I probably wouldn't choose these ordered pairs or these ordered pairs because they both have a 0 attached to them, although you could. I'm going to choose F and F prime. So I'm going to take my original and I'm going to compare it to my image. So what is the ordered pair for F? So -6, -3. So F is -6, -3. And then F prime is what? What's the order pair for F prime? -2, -1. So take these, and I mean, if I wrote them this way, let's consider this. If I just put a division bar right here, what's -6 divided by -2? 3. But with a scale factor of 3, is that a reduction? No. So if you really want to know what your proper ordered pair is, or the proper scale factor is, take your image, which is your prime, and take this and put it underneath there. So take F and put it underneath there. Or you could just reason your way to the answer. So now look at the reduction. What is -2 over -6? What does that reduce to? 1/3. So for the x values, you get 1/3. What about the y values? What's -1 over -3? 1/3. See how they're the same? So our scale factor is 1/3. And doesn't that make sense for a reduction? What's happening to your x and what's happening to your y should be the same thing. So then you can go ahead and look at, and we'll just do one additional point here. So I'm going to find the point for D just to prove to you it works. So what's the ordered pair here for D? What's the x value? 0. What's the y value? What is it? 6. So if I have a scale factor of 1/3, what do I do to the 0 and the 6 with the 1/3? I either multiply it by 1/3 or what? Divide by 3, because it's 1 over something, right? So what's 0 divided by 3? Isn't that the x value of D prime? Isn't D prime 0? And then what is 6 divided by 3? 2. And isn't that the y value of D prime? So didn't it work for that one also? Okay, so that's how you're going to find those. So now you do 12 on your own. Choose one ordered pair. I'm going to cover this up while I do it on here. It doesn't really matter which one you choose, to be honest. And I want you to discuss with those around you what you got. So did you have a reduction or an enlargement? Enlargement. And what was your scale factor? 4. So I happen to have chosen, listen, I happen to have chosen W and W prime. Because we went from smaller to larger, that's how you should have known you had an enlargement. So your scale factor should turn out to be something bigger than 1. And then I've always put W prime, or whatever the prime is, over the original. And so if you take the order pair for W prime and put it over W, negative 8 divided by negative 2 is 4, and 8 divided by 2 is also 4. So your scale factor is 4. Easy peasy, right?